Hello everyone, welcome back to MAT1033. In previous session, we already talked about how to solve rational equation, and we learned how to solve rational equation in proportional form, and in the form with different denominator. So today we're going to talk about application of rational equation. We try to solve word problem relating to rational equation. Okay, so let's put the topic for today. Rational equation. I'm sorry, I have a hole on my tongue, so kind of hard for me to talk right now. So be patient with me, okay? So I'll put the topic today. Rational equation application. Application. Okay. So before we go straight into the word problem, I just do a quick recall on a rational equation in proportional form. So we know that proportion is nothing but a ratio between two fractions, right? And one of the denominator containing variable. So this is what a proportion look like. Okay. So we have A over B equal C over D. So this is a recall, okay? We learned this last time already. And in order to solve for one of the variable here, we're going to apply the cross multiply property. So this is equivalent as A times D equal B times C. This is called cross multiply property. Okay, I know some high school teacher they used to teach you cross multiply, but they use in a wrong context. What I mean is that when you find LCD, least common denominator, and they call LCD cross multiply, it's not cross multiply. This is cross multiply. This is called cross multiply property right here. Okay. Now think about that. If we have one of the variable here is x, and the other one is just number. For example, like 2 over 3 equal 4 over x, and we want to solve for variable x in denominator here. This is a very basic, simple rational equation, because one of the condition for equation to become rational equation is the variable x must be in denominator. And to think about that, if we apply cross multiply property, we have over here 2 times x equal 4 times 3, which is 2x equal 12, x equals 6. Okay. Okay. So how with this standard basic rational equation in proportional form, we can apply the cross multiply property to solve for variable x. Okay, so we're gonna do one example of word problem, application of rational equation using cross multiply property. Using cross multiply property to solve for variable x. So it's just like any other word problem. In order to solve word problem, we have to set up variable. Okay, so I'm gonna put the first form of application of rational equation. I'm going to put over here a proportional word problem. Okay, so I'm going to put the topic here. Okay, number 1, proportional problem. It means the word problem here can be solved by set up a proportion and use the cross multiply property to solve for it. Okay, for example, I have something like this. Something like this. In US, okay, 2 out of 5 homes, 5 homes built in 1990. Built in 1990. Okay. Are heated with natural gas. Okay. Okay. So this is a word problem. Huh? At this rate, how many homes in a new community of 36,000 homes are heated by natural gas. Okay. Alright. So let's see how we're going to set up proportion here. 2 out of 5 bills are heated with natural gas. So we're going to set up 2 over 5. 2 out of 5, right? How many homes new community of 36,000? So there's 36,000 over here, which is the total. And they're asking you the how many out of 36,000 here. So I'm going to call it X. Heated by natural gas. So you see that if I say that this is rational equation, it's not quite correct, because the variable X must be in denominator, right? But we can, for this problem here, we can use cross multiply property to solve for X. But this one to be mathematically, it's not rational equation in terms of the definition we learned in previous section. You can set up like that, because this proportion here is the same as 5 over 2, 36,000 over X. This one, you see that I just need to change a little bit. So this one is not rational equation, but this one is rational equation because it's a variable X in the denominator. But this is the same thing. The answer should be the same. Okay, you can set up like this or set up like this. If you set up like this, which is much better in terms of the definition, because the variable X must be in the denominator to be called rational equation. Okay, so I'm going to use this to solve. If you use this to solve, it's still okay. Okay, so I'm going to go ahead and apply cross multiply. So I will have 72,000 divided by 5. So which is give you 72, which is let me see, 72,000 will be 14,400. Okay, 14,400 homes. Okay, so you see that this word problem we set up proportion to solve for variable X. Okay, so that's the you can there's a bunch of different other proportional problem like this, which is it's very simple. You just need to set up the ratio. Okay. For example, like you can do one of the problem here. Example 2 right here. What if I can do like this? The problem is a camel can drink 15 gallons in 10 minutes. Okay, at this rate, how much water can be drink in 3 minutes? Can the camel drink? Can the camel drink in 3 minutes? So if you notice, and you have to pay attention right over here, is that the unit must be matching up. If I go ahead and set up the ratio, right? 15 gallon in 10 minutes. How much water? So in 10 minutes, 15 gallons. See that? How much water? How much water can be in 3 minutes? So minute go with 3 minutes. Okay, and X gallon right here. This is what we're looking for. So you see that the unit must be the same. What if over here they don't say 3 minutes? They say that in 3 seconds. Then you gotta change the unit to minute, or you change the 10 minutes in here to second in order to apply a proportional cross multiply property. Okay. So now, because the unit the same, minute, gallon, so I can apply cross multiply property. So I have 10x equal to 15 times 3, 45. So I have x is 4.5 gallon. Okay. Okay. So that's the first application, the first problem of a rational equation application. I mean, because this application is so many problem. Okay, I'm just teaching you the concept, but each problem you should be exposed to different type of problem by doing a lot of homework. Okay, so you have to do homework. Okay, the second problem is the work hour problem. Okay. Okay. Work hour problem is also kind of proportional, because when you set up an equation, you look like it gives you some proportion also. But some word problem, of course, is harder than the other one. Maybe you have to find LCD and blah blah blah. But probably we're not gonna deal with that in this course. Okay, intermediate algebra. So I have something like this. Okay. Elisa can clean animal cage in 3 hours. Okay. Bill can clean it in 2 hours. How long it take them to clean together? It take them to clean together. Okay, let's see how we do this. So It is clean case in 3 hours, so it means that 1 hour she clean 1/3 of the job. Okay, and plus 1 hour, so one half of the job. So this is the job, the amount of work. So this means amount of work for 1 hour. Same thing over here. Equal to 1 over x, which is the amount of work for them to work together. So this is the amount of work for Bill. Amount of work for 1 hour. This is also about amount of work for Bill to do for 1 hour. And now you see what we have. We have a it's not quite a proportion, right? But if you go ahead and if you go ahead and find LCD, okay. For LCD, you see that over here you multiply by 2, by 2, by 3, by 3, which is give you 5 over 6 equal 1 over x. And now we have a proportion. We can do cross multiplying. So 5x equal to 6, x equal to 6 over 5 hour. Okay, that's for the final answer. So I mean, you cannot say that you don't know how to find LCD with this fraction. Okay, you cannot forget. You're not allowed to. I mean, somebody said, I forgot. I mean, you cannot forget. It's like you say that you forget how to add 2 plus 2. Nope. This is all how to add fraction here. This is elementary school. Okay, and you in college, you're supposed to know. If you don't know, you gotta let me know. Okay, then we're gonna we can spend some time in my office. We're gonna help you to do that. But you must know it. Okay, at the end, because if you don't know that, then you cannot solve rational equation. Okay, you cannot simplify rational expression. Okay. Okay. And all the word problem is like that. So I'm not gonna. Let's see. I can give you another one. But it's kind of the same thing. So let me see. I can do something like this. A local diary has 3 machines to fill half-gallon milk carton. Milk. Okay, the machine can fill daily quota in 5 hours, 6 hours, and 7.5 hours. Can fill in 5 hours, 6 hours, and 7.5 hours. How long it takes if all of them are running? To fill if all are running. Okay, kind of the same thing. So the first machine in 1/5 hours, so meaning 1 hour they do 1/5 work plus 1/6 work, plus 1 over 7.5 equal 1 over x. So all you have to do here is add the fraction here. The denominator should be 30 times 7.5, which is 225. 6 times 7.5, 45, plus 5 times 7.5, 37.5, plus 30 equal 1 over x. I'm finding LCD, okay? Multiply over here by 6 and 7.5. Multiply over here in the top by 5 and 7.5. Multiply 7.5 by 5 and find 6. So we have plus 45 plus 30. So you have 112.5 over 225 for 1 over x. So I can get x. Alright. Okay. X equals 2. Okay. 2 hours. Okay. So it's kind of the same as last time. It's just 3 machine, and this is 2 person. But it's kind of way you set up it kind of set. Okay. So that is the second problem. Okay. Now the third problem. The third problem is the motion problem. You remember, if you heard motion problem, we will have to use the d equal to rt, right? Distance, rate, and time. So we're gonna use this formula. Okay, and we have a problem like this. Okay. A tugboat take 1 2/3 times as long to go 100 miles. Upstream along the river. Along a river, and it does to return. Okay. If the speed of the current is 2 miles per hour, current is 2 mph. Find the speed of the tugboat. Tugboat in still water. Let's see how we do this. Of course, we're going to use that formula right there. All the word problem is it does require your reading comprehension. Yeah, you read the problem, you gotta put yourself into the scenario. You can imagine it is okay. So I have a tugboat and I took 1 2/3 time as long as to go to the 100 miles upstream along the river where it does to return. Right at the speed of the current is that. Okay. Find the speed of the tugboat. Okay. So we go upstream or downstream, it should be 100, right? And the time to go upstream, okay, is longer, right? That's why I take 1 2/3. If you go ahead and change this to fraction, will be 5/3. So it takes longer, right? The time it takes longer. So for upstream, time is okay, take longer. Let's see. Let's think a little bit. Let's see how we set it up. Take longer. Okay. So we got to find the speed of current the speed of current is that. So the speed of the water. So in the in the water upstream, for upstream, okay. For upstream, so the speed will be the speed and the speed of the current. So the speed of the two water, which is x minus 2, right, for the upstream, and for the downstream, will be x plus 2. Okay. So that is the speed of the boat in the current. Okay. This is the speed of the boat in the current. Okay. Okay. So we know that the upstream take longer. Will be the T upstream take longer. Okay. So the amount to go upstream, the time. So upstream, this is the information we know. The T, okay, T upstream is let me write like this. T upstream is 5/3 T downstream. Hold on. So T upstream, it take longer. Yeah. Okay. And T is equal to D over R, right? According to this formula. So T equal D over R. So we know that. So we will know D over, so T upstream could be D over R upstream, right? Equal 5/3 D over R downstream. Okay, and doesn't matter that D should be the same, should be 100. Okay, and upstream is that R upstream is x minus 2. Okay. And R downstream is x plus 2. So we 100 D over x plus 2. Okay. So I have a equation like this. You see the variable in the denominator, so this is rational equation. So I can go ahead and simplify this. So I have 1 over x minus 2 equal 1 over 3 x plus 2. If we go ahead and cross multiply, so we will have 3x plus 2 equal x minus 2. So we have 3x plus 6 equal x minus 2. Something not right. Something not right. Still water. Because over here I have a negative answer. So upstream x minus, let me see if I set it up right or not. Everything's good. Downstream x plus 2. That's weird. Upstream took longer. Minus 100. D is 10. So answer will be 2x. This is basically an equation equal to 16. X equal 8. Okay. So 8. 8 what? Speed of the current for the speed of the turbo. And this is ampere. This is the speed of the boat in still water, no current. This is speed of the boat, no current. Okay. You see? So that is that's how you do it. The way you set up, you just use this equation. Okay. And you can do something similar or some other problem. How about this one? A truck travel 300 miles through the flatland in the same amount of time. That travel 180 miles through the mountain. Okay. The rate of the truck is 20 miles per hour slower in the mountain. In the mountain. Okay. Then in the flatland. find each red in the mountain and flatland. Okay. I think this one we can use system of equation to solve, but let's try not to, because we're using the rational equation. We learn rational equation right now. Okay. Okay, so we have the distance flat land right here. So D1 is distance of flat land and D2 is a mountain so the red in the mountain, in the mountain is slower. So if I call R is the red in the mountain, okay, then R plus 20 is the red in the flatland, because flatland is faster. Same amount of time. This information important. So we know that T equal D equal RT, so T equal D over R. Because the T is the same, so from here we know that D for the flat land will be 300 over R plus 20 equal to 180 over R. Alright, so I have a rational equation in proportional form right here. So I have 300R, 180R plus 180 times 20, 3600, 300 minus 180, 120R equal to 3600 R. Okay, divide by 120, so R will be 30 amperes. Okay, that will give you the rate of the truck in the mountain. Then this is in the mountain. In the flat land, you just add it. R will be 30 plus 20, 50 amperes. There you go. Okay. Alright, so I think I just introduced 3 problems of rational equation application. I'm gonna stop right here. If you see any other problem, try to set it up like this. Okay. If you see another form, please let me know. But if I give you something like this on the test, I'm gonna just pick one of the problem here. Okay, so I'm gonna stop the video here. Please let me know if you have any question. I will see you next time in the next video. Bye bye.